Hi everyone, this is Mr. Campagna. This is lab number 4, the Hertzsprung-Russell diagram. So if we take a look here, it says astronomers use two basic properties of stars to classify them. These two properties are luminosity and surface temperature. Luminosity usually refers to the brightness of a star relative to the brightness of the sun. Astronomers will often use a star's color to measure its temperature. Stars with low temperatures produce a reddish light, while stars with high temperatures shine with a brilliant blue-white light. Surface temperatures of stars range from 3,000 degrees Celsius to 50,000 degrees Celsius. When these surface temperatures are plotted against luminosity, the stars fall into groups using data similar to what you will find in the plot in the activity. Danish astronomer Einar Hertzsprung and U.S. astronomer Henry Norris Russell independently arrived at similar results in what is now commonly referred to as the HR diagram. So your purpose today is to make a Hertzsprung-Russell diagram. Your procedure is to plot the stars listed in the data table at right or below and on the graph paper provided. Draw a circle around each grouping of stars on your chart. How many groups did you circle? Label the following on your graph. You're going to label the main sequence, the red giants, the white dwarfs, and the supergiants. That's going to look just like what you see on Earth Science Reference Table, page 15. Circle the dot representing the sun. And then lastly, what type of star is the sun? So let's take a look at the ones that we have here. We have our first one, which is the star Orion. That luminosity of 10,000 and has a surface temperature of 20,000. Now, considering here we have times 1,000, we're just going to go with the 20 on the bottom and the luminosity of 10,000 on the side. Now, you might not have seen a chart just like this before. Pull this out a little bit. So this is what we call a logarithmic chart. Let's look at the scale on the side. Now, you can see here that we've got 1.0, 2.0, and then you'll notice it jumps to 4.0. Then it jumps to 6, then it jumps to 8, then it jumps to 10. So you notice in this section right here, we're going by 2s. Over here, we have a 10. Notice we jump to 20. Then the 20 goes to 40, 60, 80, 100. So here we're going by 20s. Another example would be here we have 100, going up to 200, and then again we jump by 2s. So there's 200, 400, 600, 800, 1,000, 2,000, 4,000, take a guess. That's right, 6,000, 8,000, 10,000, 10,000, 20,000, 40,000, 60, 80, 100,000. Now along the bottom of the chart, you have your surface temperature, and they already have it multiplied by 1,000, or that's the unit, right? So in that case, that would be 35,000, 30,000, 25,000. But if you look at the first page, they don't even give it to you like that. They just give it to you plain here. So in this case, it says 20, and then that means it would be 20, right? Just as simple as that. One other thing, it looks like on some of the handouts that's a 6. It's not a 6, it's a 5. So that'd be 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you'll notice now we're going by 2s. So in that case, it would be 2, 4, 6, 8, 10, 12. Then in this case, 20, 25, 30, 35. All right, so let's go to that first one again. That is 10,000 and 20 for the surface temperature. So let's find 20 for the surface temperature to start, which would be right there. And we're looking for 10,000, so I'm going to move my paper up. And there's a 10,000 right there. And I'm going to find the spot where both of these guys meet. Zoom out a bit so you can see the whole thing. And if we go all the way up and we cross that spot right there, that first one right there, see where the two spots intersect, that will be Orion. Let's do number 2. Number 2 is the star Betelgeuse. Betelgeuse is 20,000 for luminosity and has a surface temperature of 3. Really, it's 3,000. 20,000 Celsius, but 3 on the chart. So we're going to find 20,003. So 20,000 is right here. And 3, this was from number 1, and 3 would be right here. Now you don't have to number them on the sides and bottom. I'm just doing that to make it clear for you guys. So 20,003, so let's go straight up on this 3 line until we bump the 20,000, which is right here. And we're going to label this one Betelgeuse. So this was number 1. This is number 2, and it's spelled Betelgeuse, Betelgeuse. All right, cool. Let's do 1 or 2 more. We've got Polaris, which is number 3. That is 6 for luminosity and 5.9 for surface temperature. So 6 for luminosity, that's 1, that's 2, that's 4. 6 for luminosity would be right here. That would be number 3. And we're looking for 5.9. Well, that's 4, that's 5, and that's 6. You notice we're increasing as we move to the left for these guys. So where would 5.9 be? Sorry about the camera. Where would 5.9 be? There's 5. 5.5 would be right in the middle, right? So 5.9 would be just to the right of 6. So I'm going to put an arrow right here just to the right of 6, and I'm going to label this one as number 3. So we're going to come on up. We're going to intersect with our 6. So let's go up. And we're looking right about there. And that one was Polaris. And that was number 3. All right. What do you say? One more? Akmar, which is 2,000 for luminosity and 24 for the surface temperature. 2,000 for the luminosity, which would be right here. We're going to do number 4 for that. And 24 for the surface temperature. Well, there's 25 right there. So where would 24 be? 20, 21, 22, 23, 24. We're just to the right of the 25. So that would be number 4. And we're going to see where these two intersect. So I'm going to go up, and I'm going to drop my dot right about there, and I'm going to label that number 4, and the name was Akmar. All right, cool. Now, once you have all these down, we're going to be looking for some patterns. So let's look for our Earth Science reference table. In fact, I'll put one up right now on the computer. All right, we're looking for page 15. Okay, so now you're going to notice that right here we have our main sequence, we have our white dwarfs, we have our supergiants, and our giants. And looking at yours, you're going to find a similar pattern. You're going to find the main sequence goes something like this. You're going to find supergiants, giants, and white dwarfs. Other than that, you have a few questions on here. Questions like, how many types of stars are shown? Well, we just saw the groups on page 15, so you know that. How does the brightness and temperature of the sun compare with those of other stars? Well, number 12 is the sun, and you're going to see where that is, 1 and 5.7. So if we look, we're looking for 5.7, that would be like right about here with a 1. So we're right about here. So where are we? Are we an average star? Are we super bright? Are we super hot? Remember, brightness increases, B-R-I-G-H-T. Brightness increases as we go up. Also, star size increases. So these guys are all big up here, and they're small down here. And all the way to the left, we've got super, super hot. And over here, we've got cool stars. But that's basically it. I mean, lab number 4 is a pretty straightforward one. Pretty simple. Should be able to get this done in 30 minutes or so. It depends on how long it takes you to plot those. I think it's good practice for just plotting points as it is. But if you have any questions on this, let me know. Other than that, have fun, and hope this was helpful. Bye.